hydrodynamic diffraction and the array vex. And if you have some questions related to these topics, you can ask me. Here we are going to talk about five topics that are related to the VEX modeling. First of all, we are going to talk about some initial informations and introduce you to the ANSYS and specifically the ANSYS AQWA. In the sorry for the numbering was the wrong. I forgot to correct it. In the second part, we are going to talk about the AQWA basics and the principles behind the AQWA and the main theory of the ANSYS AQWA. And in the remaining parts, we are going to specifically talk about the geometry and the preparation, the model to analyze in the ANSYS. Okay. First of all, the ANSYS AQWA is a three-dimensional hydrodynamic analysis software that is based on the radiation diffraction method, and it uses a theory that is based on the linear potential flow theory. And also, the AQWA is a finite boundary approach. I mean, some softwares that you may know, like the ANSYS Fluent or CFX, uses the finite volume method, but in the ANSYS AQWA, the method is based on the finite boundary method. The capabilities of this software, capabilities of the AQWA, we can simulate the radiation diffraction and also the hydrodynamic interaction between bodies when you have multiple bodies, and for instance, when you want to model the arrays of the VEX, you can use these capabilities. And also another important thing may be the modelings of the moorings. About you may know the moorings lines and the tethers of the VEX is another important parts of the modeling in the VEX. And also the fenders or articulations, and in the time domain analysis, you can add the wind or currents, and you have the different types of irregular bays. And about the results that you can extract from the ANSYS, you may have the response amplitude operators and the motion structures, and also the moments and the forces of the moments and forces that are affects the structure. And also the multiple body interactions that I mentioned before, and the VIB that are we have some types of VEX that are based on the VIB. You can model them with ANSYS AQWA. And now in this part, we are going to talk about the AQWA basics and the main theory behind the AQWA. There are two.
Sorry, Hassan. Yeah. Try to pass one slide forward, just for us to see.
Okay. Okay. There are two. Generally, there are two methods to solve the hydrodynamic problems. The first of these methods is the potential flow that is based on the potential flow theory, And another method is the computational fluid dynamics. If we want to compare these methods, the potential flow has the fewer and the less computational time to solve the problems in comparison to the CFT method. The potential flow method uses the linear potential flow theory, and some softwares like the ANSYS AQWA has this method. While if you want to have the CFT method, you can use some softwares like ANSYS Fluent and CFX. And the main method behind the CFT method is the finite value method, and it can also simulate the turbulence model. So you have to choose these softwares based on your project. I mean, if you want to model the turbulence models behind the hull or ships, you have to simulate your structure in the ANSYS Fluent. While if you have some simple assumptions that you may know that in the potential flow theory, the fluid is in viscous and the irrotational. So these assumptions maybe input some inaccurate results in your modeling. So the ANSYS Fluent and CFX may have some more accurate results rather than the ANSYS AQWA, and you have to choose to do with these two methods. As I mentioned in the last slide, the main theoretical assumptions and limitations of linear potential theory that is used in the ANSYS AQWA is that the fluid is inviscid and incompressible, and also the irrotational. In the ANSYS AQWA, the forward speeds of structures is assumed to be the zero or very small. In this software, the frequency domain analysis and also the time domain analysis is possible to do. And in the frequency domain analysis, the main equation is based on this equation that you can see. These are some parts, different parts. I mean the mass matrices that is included the structural mass matrix and the hydrodynamic added mass matrices that is calculated after the hydrodynamic frequency domain analysis. The C, I mean the damping matrices and the hydrodynamic stiffness matrices also will be calculated after the frequency domain analysis. And the wave excitation forces part consists of the Foote-Grillo force and the diffraction forces. And these are the main hydrodynamic parameters that are calculated after the frequency domain analysis, and you may need to put these parameters to the time domain analysis to have structure motions, accelerations, and velocities in the time domain. So the use of the frequency domain analysis is generally based on the calculation of these hydrodynamic parameters. And in this software, another important thing that you should know is about the coordinates. There are two types of coordinates: the global coordinates and the local coordinates. The mass and the mass properties, I mean, like the mass of the structure, center of gravity, moment of inertia of the structure is input as the local coordinates. And but the results of the motion structures and another results that you get from the ANSYS can be calculated based on the both the global coordinates and the local coordinates. In this picture, you can see the 6 types of floating offshore structures that you may know about them, and it's not so important to know. Okay, for the remaining parts, first of for the preparing the model to be analyzed in the ANSYS AQWA, you have to do some preparations like the geometry, preparing the geometry, the setup part, and the last one is the processing settings. First of all, about geometry, you can import the geometry from the exiting file, and also you can create your geometry in the own environment of the ANSYS. In the ANSYS, you have 3 different types of environments for creating the geometry. The first of them is the design modeler, that is an old environment of the ANSYS for the creation of the geometry. But in the for the another environment, the SpaceClaim and the ANSYS discovery are works for the creation of the geometry. The design modeler and SpaceClaim are the most popular in the ANSYS for this purpose. And if we want to compare these 2 environments, the design modeler is suitable for simple geometries, while if you want to have some more complex geometries, you can use the SpaceClaim. The design modeler has more I mean you need it's so hard to learn the graphic interface, but the SpaceClaim is more user friendly, and it's so simple to learn about modeling in that environment. Another thing is that the SpaceClaim is in the development mode, and ANSYS the ANSYS solves its bugs, and the improvement of the SpaceClaim is more efficient than design modeler. Also, the SpaceClaim is newer than design model that I mentioned, and in the year 2014, it is attached to ANSYS. For the some it is some essential you have to do some essential works to prepare your model in the AQWA. I mean, you have to do this essential things to that AQWA can read and analyze your model. First of all, you have to put your structure along the z-axis vertical up, and also your model have to be consist of lines and surfaces. If your structures consist of solid parts, the AQWA can't read these types of structures, and it can't be analyzed. So ensure that your model consists of lines and surfaces. If you have multiple bodies, you have to put each body in a separate component. So the results would be separate, and you can extract the results separately for each structure. And another important thing is that you have to put the global coordinates on the still water level. In the ANSYS versions 2020 R1 and the previous versions, you have to separate your diffracted part and non-diffracted part. I mean the parts of the structure that are above the border and below the border. You have to separate these parts. But in the ANSYS versions 2020 R2 and the next, you don't have to do this, and ANSYS automatically does this. It is important. This part it is important for the creation of the nodes in the still water level, and as I mentioned in the previous ANSYS versions, you have to do this manually, but in the new versions of the ANSYS, it is done automatically. Okay. If you have any questions, you can ask, and if not, we can go to the ANSYS and have the modeling of the geometry.
I think it's okay for now.
Yeah, that's good. So we try to use ANSYS already, and we have a few problems because I think it's just a matter of learning how to use and how to set up the things in the simulation. So, for example,
Okay.
Drawing the geometry, it's
Okay.
like very similar to other software, but like how do you, when you reach the model part on the hydrodynamic diffraction block, how do you pull that geometry into that? And on the simulation, how do you set up the values and the parameters, that kind of stuff?
You mean you create your geometry in other types of geometry creation softwares, and you want to import this in the hydrodynamic diffraction, or you have some problems?
No, you can go step by step in there, and I can ask you when I have the questions regarding what you're explaining. That's no problem.
Okay. Are you introduced with this with the workbench of ANSYS or not?
Some of us knows it a little bit, but if you can go from zero, I think it's good for us.
Okay. This is the general workbench of the ANSYS, and in this page, if you have different types of the different, if you want to use different analysis in the one project, you can add these different types in this page. I mean, you can create your model in the SpaceClaim, and this is the SpaceClaim software. You can drag and put it on the project of the workbench. This is the SpaceClaim. If you have if you want to use the ANSYS AQWA, the hydrodynamic diffraction and the hydrodynamic response are the ANSYS AQWA software, the hydrodynamic diffraction is used for the frequency domain analysis, and the hydrodynamic response is used for the time domain analysis. And you can again drag and put it on the geometry, and you can see that the geometry imported to the hydrodynamic diffraction software. And also you can done and create your geometry in each of the these softwares. I mean, if you put a static structural, you have the geometry part in this, and you can click right on the geometry, and you can see that these different types of importing geometries exist. Or you can, the way I said, you can put your software in the geometry, and the geometry is imported. If you click right on the geometry, you can see that, excuse me, these are the the various types of importing geometry that I mentioned: the import geometry, design modeler, and a SpaceClaim, and the discovery geometry option. The discovery geometry option is the newer environment of the ANSYS to model your geometries, but it is more about for the complex, more complex extractions. But for the wave energy converters, the SpaceClaim may be the suitable environment. Okay, and if you have, I mean, different, if you want to use different softwares, you can drag and put it on the workbench page. For example, if you can create your geometry in the SpaceClaim, and you can put it on the hydrodynamic diffraction and analyze the frequency domain of the model, and after that you can extract the pressures and the structural forces, and you can import these results to a static structural, for example, environment, and you can analyze the structural and also, if I want to show you, you can drag and put it on the solution, and the results of the hydrodynamic diffraction is imported to the static structural, and you can analyze it in the static structural. And also about the time domain analysis, you can drag the hydrodynamic response and put it on the solution, and it is automatically the results of the hydrodynamic diffraction and the frequency domain analysis is imported to the time domain response analysis, and you can analyze your structure in the time domain. But we don't have needed. Okay. For the geometry, I will start with the SpaceClaim. You are going to click right on the geometry and the new SpaceClaim geometry.
If you can show us how to draw something very simple, for example, a cylinder or something like that, because I have some questions. Yes. Like how do you make it a shell? You know, the two, the base, the top, and the if you can do that.
Okay, sure. You mean you have the solid parts and you want to make it as a shell, is it right?
No, not even that, like even the simple geometry itself, like how do you build a cylinder that is closed at the top at the bottom?
Okay. This is the SpaceClaim environment, and as you may see before, the units in the SpaceClaim is based on the millimeters. But if you want to change these units, you can go to the file, SpaceClaim options. Sorry. And in the advanced part, excuse me, units. In the units part, you can use another units for your modeling, like centimeters, meters, or other things. And in the advanced part, you can change the orientation of your global axis. I mean, you can see that the default is Z vertical up, and you can change it to Y or X. But the Z is suitable for the ANSYS AQWA. As I mentioned, you have to put your structures in the components, and it is so essential when you have different multiple structures. You have to put each of them in a component. So you click right on the design and click on the new component. And everything that you create here, it is attached to the wake part. Okay. Uh, First of all, you have to click on the sketch mode to choose for which of the coordinates you want to create your model. I click on the X, and we can see that we can sketch our model on the YZ plane. There are various types to create your model. For example, for a cylinder part, you can use the cylinder, and your cylinder is made in the whole shape. But another types of creating models that are very simple, that this types is that you can draw your half of model and pull it along the z-axis, and your whole model is made. I will show you these types of modeling, and you can choose what's your way. But for the complex structures, the second way is more simpler than this part. Okay. For a simple cylinder, we can use this manner. For example, we can draw a circle with a dimension of 10 meters. And with the option of the pull and drag, you can make a cylinder. I mean, you can see that when you should click on the pull, and when I put my mouse on the surface of the circle, you can see that the pull option is on, and you can click on the surface and put it and drag it, for example, for a distance that you want. For example, a cylinder with 10 meters diameter, 10 meters dimensions, and with a height of 5 meters. If you can see that this cylinder is contains of a solid parts, and if we import this model in the ANSYS AQWA, it can't analyze, and you have to make it as a shell. There are different ways to do this. For example, if you click on the solid part, first you have to select it and then click on the solid part, and the detach all option makes the solid parts to the shell and line. You can see that these are three shells that a cylinder is contained. But if again, if we import these types of model in the ANSYS AQWA, it may have some problems. It can be analyzed, but if you remember that in the setup parts you have to import the mass and the moment of inertia and the center of gravity of your structures. And if you import this model in this manner, each of these shells need to be imported, and the mass and the moment of inertia separately. And it is not so accurate, and it may have some problems. So you have to put these three shells to a one shell. And again, we put them in the one section, and again we change them to the surface. For combining, you are going to the design part and select your shells and click on the combine. And you can see that your shells are combining, but due to the that your model was closed and it wasn't an open area, your shells are going to be solid again. For to change and to combine your shells to one part that aren't a solid part, there are different ways. You can put a small circle on the top of your model, or you can also have a surface, for example, in the half of your model, and separate your model. And if you detach your solid part, it changes to the shell. First of all, we put the global coordinates on your water surface level, and after that I will change the solid part to shell.
Just
The
how to
first one
set up
simulate.
the simulation and how to change the parameters, how to do all that. Because, for example, this drawing that you made, it shows a lot of things to us that we don't know. Like even
Okay.
the basic stuff really helps. So I think that's very good.
Thanks. Okay, I show you that this part. To define the draft parameter of the offshore structures, you have to put your global coordinates on the still water level, and you may know you have to select these parts, and you can use the move option. That in the move option you can rotate or move your structure along the axes. We want to put the global axis in, for example, in the half of the cylinder. And excuse me. It's an ANSYS box, but sometimes it didn't work. Okay. For example, draft with 20. And the draft part is the 2 meters and 2 meters, and in the previous versions of ANSYS you have to separate the diffraction part and non-diffraction parts. You can do this by this manner. First you have to put a surface. You can use this in the design parts and create a surface. You click on the z-axis, and the surface is put it on the global surface on the surface waterline. And after that, you have to split these parts. You go to a split option and click on your surface, and on your surface that you made. And your parts are separated. As you know, the parts underwater is a diffracted part, and above the water is non-diffracted part. And you can delete the surface, and your structure is separated on the water line. And after that, you can detach this part and make the above part combined and the diffracted part. In the previous versions, you have to do this to create the waterline nodes on the waterline. But in the newer versions, ANSYS do this automatically, and you don't need to do this. In the previous versions, again, this way works for making your structures to a shell. But in the new versions, you can do another way, and again I make this a solid part and show you. We can put a little circle, or I mean, we want to make an open area on the surface that when we combine our shells, the shells don't make a closed form part, and they don't be a solid part. As you know, in ANSYS AQWA, the hydrodynamic analysis is based on the diffracted parts, and all of the hydrodynamic coefficients are calculated based on the diffracted parts. And the non-diffracted parts are less important, and they may be need to analyze the structure. I mean, when you want to import your results in the static structural that I show you in the workbench, and the non-diffractant parts may be needed on that part. But in the hydrodynamic diffraction analysis, the only parts of the structure that is diffracted is analyzed. So when we create an open area in your non-diffracted parts, it doesn't import any errors in your results, and it don't make some changes in your results. It is not affecting, I mean. So I put an circle on the above my structure. For doing this, I create a circle. For example, a small circle. Okay, and now we delete the circle that we made. And finally, our solid parts makes a open. I mean, the final structure is not a closed form, and when you combine your shells, they don't meet, they don't make a solid part. Now we can see detach this part and delete the circle surface. If I delete this, our structure won't make an closed form shell. If we combine them now, that we can see that we have a one part structure that is surface and concluded the consists of a shell, and we can rename it to float part. You can make your solid parts with this manner to make them shell parts, and then import it to your ANSYS AQWA and analyze them.
Hossein, I have a few questions here. So first, you moved the geometry in the z-axis.
Yes.
That's to put the geometry on the surface water level. Like at which point exactly is that? Is it the middle?
I put it with a specific number that I import. I mean, you can change it to another parameter that you want.
Okay, so you have to make that cut on the section where the area, where the water ends, right?
For the separating the structure, it was about the previous versions, and I want to show you that, and you can also use it as a manner to make your solid part to a shell part. But in this manner that I show you, it's for the newer versions of the ANSYS, and it's so simpler. But for the moving parts, you may have some questions. Yes.
I'm just wondering, how do you know like where to make that cut? Like, how do you define the distance for that, the measure for that?
When you want to design a wave energy converter, the draft parameter, you may have to define a draft parameter based on your geometry, and it is not a specific. I mean, it's based on your design.
Okay, so I'm basically saying like how much of it will be out of the water. Is that it?
Yes, I put it, for example, in the middle of the cylinder, but it is based on your design. It can be, for example, 1 meters or 2 meters, each parameter that you want. It's not a specific. It's an example that.
Yeah, okay, but you don't have to put a density value for this material, so ANSYS can know
No.
like the buoyancy force and all of that. You don't need to change that.
About the mass and the mass properties of the geometry, I want to talk about them in the setup parts. But because you asked, the mass properties of the structures in the ANSYS AQWA is calculated based on the water density and the wetted surface of the structure, and it doesn't related to the, the density of the structure.
Okay, maybe you can do that in a second encounter. So that's okay for you?
Yes, the set of parts and the frequency domain analysis, I will tell you about them.
You mean in the next one or right now?
I mean,
because I don't know if you have a problem with your time now.
No, if we can, I can tell you for the next session, next week.
Yeah, okay, next one.
Okay. Another thing I want to tell you about the geometry, you can add another structures, for example, for arrays of vex, or when you have a geometry of the vex that is consists of a two-body vex, like a two-body vex, point absorbing vex. Again, you can make a new component, and for example, submerged. You can off your disk, and you can see that the first part that you make is invisible, and everything now you create is automatically put in the second component that you make. And for example, you can make another parts of your wake, or another geometries for another in the arrays of a wake. After you create your all of structure parts, you have to click on your component, and in this tree, in the shared topology part, you have to put it on the share. It doesn't matter on, for example, this simple structure that you have just one part in your component. I mean, if you have another part, like then you have a S bar on your wave energy converter. I mean, when you have two different structures in one component, if you don't put the share topology option on share, when you get the results in ANSYS AQWA, you can, I mean, the results are separate, but in the analyzing the structures, you may want to have the complete, for example, motions of this structure. For example, if we have a S-bar in the middle of this cylinder, we want to know about the motions of both the cylinder and S-bar at the same time. When we don't do this, the results are separate, and it's so important. Again, for the another components, we should put this on the shared topology. Just this, but for example, for creating a cylinder, it's another way. This manner I showed you was one way. Another way I can show you. It's helpful because you can create your half of your structure. For example, and again, with the pull option, you can rotate these lines along the z-axis, and your model will be created in this part. And click on the z-axis and select your lines. And again, your cylinder is created. This way for creating your geometries is simpler than other ways, because then you have the more complex structures. In this way, you can create your models in very fast and it's more accurate than if you want to, for example, make a cylinder and a sphere and glue them and makes them for I mean makes them just one part. It's maybe more complex and hard, but this manner it's so simple. And again, you can make it to a shell part. It's just about the geometry parts. If you have any questions, you can ask me.
I think that's all good.
These are the general informations about the geometry. But if you have any questions about the details, again, you can ask.
Mhm.
You can
I
make
think
a
that's
simple
okay.
model.
Yeah, I think we can leave it at that for today. If you don't mind, we're having another one of these sessions on next Tuesday at the same time.
Yes, it's so good.
Okay,
It's
then we
fine.
can go to the frequency domain analysis in the simulation.
Sure.
Okay, that's great. So just a small remark, you don't need to like prepare nothing very advanced for us, okay? We are just like a student group here. You don't need to worry about that. Just you can come with a, I don't know, a geometry drawn at maximum. That's it. You don't need anything else than that. Don't worry about it. Okay.
I think if we work more on the environment of the ANSYS,
Yeah.
it's would be more useful than the
Yeah,
slides.
I think it's
Yes.
our question is more like on how to use it. So I think that's a good idea.
Sure.
Okay, so thanks a lot for your time today.
Thank you so
Have a
much,
good day.
Hassan. Nice to meet you. And thank you for your time.
Nice to meet you too. Thanks.
Okay, so see you next week. I will send you the invitation again.
Thanks. Okay, sure.
Okay. So bye-bye.
Have a good day.
See you.
Bye bye.